Let's take a look at this very interesting example. Please notice that we have given just total admittance and voltage source. We're supposed to find the following quantities. The problem at the very first moment can look very complex, but I will show you that this is actually a very simple one. So, first we have to find the conductance and inductive susceptance. So, how are we supposed to look at the given information? You're supposed to copy down Y total, because Y total has to do with G and BL. So, Y total is equal 50 millisiemens minus J 40 millisiemens, where the real part of my total admittance expressed in rectangular form is representing the conductance. So this is actually my G. And negative J 40 millisiemens is nothing else, just my BL. Okay? So I found already G and BL. If you want to express BL in the polar form, you're supposed to write that BL is equal 40 millisiemens and angle of negative 90 degrees. Okay? Now we can find very easy Z total. Z total is equal 1 over Y total. So I have 1 divided by 50 millisiemens minus J of 40 millisiemens. Okay, if you are going to switch your calculator to polar form and calculate this fraction, you're supposed to obtain 15.61 ohms and angle of 38.66 degrees. Okay, so this is the total impedance of my circuit expressed in polar form. Next, we have to find the resistance. Now, you're supposed to remember that resistance is nothing else, just the reciprocal of the conductance. So I have 1 divided by 50 millisiemens. Okay, this is my conductance. So this is equal 20 ohms. Next, I'm supposed to find the inductive reactance. Okay, so I have X of L is nothing else, just the reciprocal of the inductive susceptance, BL. So I have 1 divided by 40 millisiemens, okay, and angle of negative 90 degrees. This is equal 25 ohms and angle of 90 degrees. So this is the inductive reactance in my circuit. Next, I'm supposed to find the voltage across the inductor. Please notice that we are talking about the parallel circuit. In parallel circuit, voltage across each component is the same. So I can say that voltage source is equal VL and is also equal voltage across the resistor. So what we have given? We have given the voltage source, right? So voltage source is equal to VL, VR, and has a value of 12 volts. Okay? So next we can find I total. I total is equal voltage source over Z total. Okay? Where voltage source we said is equal 12 volts, okay, and divided by Z total, which is equal 15.61 ohms, and angle of 38.66 degrees. This is equal 768.73 milliamps. And angle of negative 38.66 degrees. Okay, so this is the total current in my circuit. Next, I'm supposed to find the current which goes through the resistor. Okay, so we have IR is equal voltage source, but keep in mind that voltage source is equal to the voltage across the resistor. So I'm supposed to write also VR. You can write VS or VR, it doesn't matter because both of them have exactly the same value. So VR over resistance is equal 12 volts over the resistance, which is equal 20 ohms, will give me 600 milliamps. Now we're supposed to find the current which goes through the inductor. IL is equal VL over X of L, where VL is equal 12 volts and X of L is equal 25 ohms and angle of 90 degrees. So this is equal 480 milliamps and angle of negative 90 degrees. So this is the current which goes through the inductor. Now we're supposed to verify if our answers are correct. So I'm going to use KCL to verify my I total value. So if I total is equal IR plus IL, where IR is equal 600 milliamps plus IL, which is equal 480 milliamps and angle of negative 90 degrees is equal 768.37 milliamps and angle of negative 38.66 degrees. Now, next we're supposed to compare these two values of currents. As you can see, they are close enough, right, to say that they're almost the same. So we can say that our calculations at this moment are okay. Now we can find power factor. Okay, so the formula says power factor is equal cosine of the angle theta, which is next to Z total or Y total. Because we found Z total, I'm going to use Z total angle. So I have cosine of angle 38.66 degrees. This is equal 0.78 lag. Why lag? Because the current in RL circuit always lag the voltage source, okay? And in this case, the current is going to lag the voltage by 38.66 degrees. Next, we're supposed to find reactive power. QL is equal 1/2 VL to the second power over X of L. So I have 1/2 VL is equal voltage source, which is equal 12 volts, to the second power over X of L, which is equal 25 ohms. So QL is equal 2.88 volt amp reactive. Okay, so this is the reactive power in my circuit. Next, I'm ready to find the series equivalent circuit. So in order to do so, we're supposed to write one more time Z total, which is equal 15.61 ohms and angle of 38.66 degrees, and convert this to the rectangular form, which is equal to 12.19 ohms plus J 9.75 ohms, where the real part is my resistance Rs, the imaginary part is my inductive reactance X of Ls. Okay, so next we can find the inductance of the inductor. In order to do so, I'm going to use the formula for the inductive reactance. So if X of Ls is equal omega Ls. Solve this formula for Ls by dividing both sides of my formula by omega. Omega will cancel out, and I have Ls is equal X of Ls over omega, where X of Ls we found is 9.75 ohms over omega, which is equal 4 times 10 to the 6 to the 6 radians per second. So this is equal 2.43 microhenries. Okay, so this is the inductance of my inductor. And next, I can draw the series equivalent circuit. So this is my Rs, this is my inductor, Ls, which is equal 2.43 microhenries, and Rs is equal 12.19 ohms, right? And this is of course my voltage source, which is equal to this. So we can say that the problem is solved.